Good morning or afternoon, everyone, depending upon where you are. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I want to welcome you to the Intelligent Testing Revolution. Today's program is brought to you by testing solutions provider SOSTA, and is chock full of great information. Before we get started, just a couple of things I'd like to point out. At the end of today's presentation, there will be a live Q&A. So at any time during the presentation, you can type a question into the control panel there and hit submit. And when we answer them at the end of the program, we'll get to as many as time allows. Secondly, today's webinar will be available on demand at sdtimes.com in the resources section, probably within the next 24 to 48 hours, and then you can watch it over and over again to your heart's content. So the Intelligent Testing Revolution. As we've been reporting in SD Times, new software architectures today and the new platforms have led to big changes in testing. And today's webinar will explore the details of how test plans are typically created and how they can be drastically enhanced and even automated by using actual user behavior data to ensure accuracy and efficacy. Your takeaway from today will be an actionable answer to this question: what should I test and how should I test it? So today's presenters are Dan Bartow. He's a principal product designer at SOSTA. He is addicted to great design and is currently leading work on real-time data visualization, data science, 2D, 3D UI, and R&D for the award-winning products at SOSTA. Also presenting is Lauren Younger. She's Director of Product Management, and she's responsible for SOSTA's Impulse, Data Science Workbench, and Digital Operations Center products. So now here to get us started is Lauren Younger. Lauren, take it away.
Thanks, Dave. So welcome, everybody. Thanks so much for joining us today. As Dave mentioned, we're going to talk about some real ways that we've been able to use Impulse data and data science at SOSTA to create very accurate and effective test cases. So we're calling this new product run-based testing. So what is run-based testing? Everybody is looking for the holy grail of testing. So before I was a product manager, I was a tester, and we always wanted to make sure we were testing the right thing, we were testing enough, we weren't wasting our time, we weren't missing those cases, because you never want to be the one that's missed something and then there's repercussions for that. So throughout time, there's been many people searching for the holy grail. Monty Python, Indiana Jones, even Jay-Z has searched for the holy grail. So testers are no exception. Developers are no exception. So everyone has to test, so you might as well test smart, right? And that's what we're trying to help people do. And if you don't know what you're testing, you're only testing, and in quotes, right? You can make some effort, you can cover some cases, but if you're not sure about what you need to be testing, then if you hit one of those untested cases, you may well have not tested. So I'm calling that testing in quotes. And then if you're only testing in quotes, we know what happens, right? So here's some examples of some recent, very public scenarios that weren't tested. So HSBC, people didn't get their paychecks. Delta, we've all seen this recently in the news with the long wait. Pokemon Go launched, huge successful launch, huge issues that could have been tested for. Maserati, I love this, that their site's down but their video's up, so thank goodness for CDNs, right? Southwest Airlines, another airline, and we're seeing this more and more with the airline industry, that their backends haven't been tested. They're not ready for today's use cases, and that's really what run-based testing is about. What are today's use cases? Amazon even goes down. Star Wars pre-sales took down multiple ticket sales sites, including Fandango. And then my personal favorite, Beyonce, after the Super Bowl, announced her concert, and her site crashed with all the traffic. So just some examples, and also just proof that this happens to everyone, right? So how can we be very effective about our testing? How do you know what to test? So you can look at that RUM data. With Impulse, you have every single user experience. There is no sampling. And you can't get this from marketing analytics. So I know that a lot of test cases do come from marketing analytics, and that's a good place to start, but it doesn't give you every user experience, and it doesn't have the data science backing it up. So only Impulse gives you all the data all the time, kept forever. And the kept forever part is important because if you want to potentially test for some event that is an annual event or a quarterly event, you can take that data from those previous events and use that to build the test case for that event for this year. So you want the data, here's your data. Dan and I were joking about what nerds we are, so I'm a total Trekkie. I'll let Picard speak for me any day. So here's your data. With the Impulse data, you're able to know exactly what you need to test, from where are your users coming from, at what volume, where are they coming from in larger volume, what are areas where maybe you don't realize you have some users that you need to test for. Maybe it's on a different type of network. Maybe they have different behavioral patterns. And then over what time? How long are they on your site for? How long do they think on each page? So run-based testing from SOSTA is very specific in what it delivers. It delivers you a complete test plan. It includes specific session path recommendations, think times for those sites, the geographic load generator locations. We can even let you choose which service provider you'd like to use to create that load, and the ramp time. How long do you need to take to get up to that load? The takeaway from this, what this is going to enable you as testers or site owners to do is test very efficiently and effectively, right? You're going to be able to reduce your test risk. Because you're not going to be just kind of ad hoc testing on your site. You're going to be able to go on your production site and test very specifically, and so you're going to reduce that risk. You're going to reduce that cost. It's not going to take you as long to test. You're not going to create any unnecessary load that you're paying for. And ultimately, you have a higher quality website, and that's going to increase your revenue and your bottom line. So that's my intro. We love to just demo things around here, so I'm going to hand it off to Bartow, and he's going to take us through a demo of this. So Dan, you want to take it away?
Absolutely. Yeah, thank you very much for that, Lauren. That was an excellent job of setting this up. And my job here today, coming out of webinar retirement, I haven't done a webinar in almost 5 years. I only like to stick my head out when there's something big to make some noise about. And this is definitely that thing. We need to make some noise about this. My job here today is to tell you why what you're seeing is so game-changing and has never been done before. But before we get into that, and by the way, in a lot of ways, this test plan creation functionality is, in a lot of ways, my life's work. So in order to explain why, I need to take you through just a little bit of a history about Dan Bartow. So from 2000 until 2007, I worked for a company called ATG. And at the time, they had the leading e-commerce platform in the industry. And for 7 years, I went week to week, month to month, doing performance engineering engagements to make sure that the very large, high-traffic retailers that were our customers could survive their peak seasons, usually Black Friday, Cyber Monday. And so over 7 years, I visited hundreds of customers, companies like J.Crew, Neiman Marcus, the FAA, even the U.S. Army was running their soldier portal on the ATG platform, American Airlines, Oprah, Best Buy. Key theme here being really high-traffic sites, really popular, under heavy load. And so my job was to make sure that they didn't crash in their peak traffic periods. Then from 2007 until 2009, I was at Turbotax Online, where I was senior engineering manager, responsible for the performance and stability of Turbotax Online. So took what I learned over those 7 years and applied it to a single web application, single very high traffic application, which also had peak periods, around tax time. And then in 2009, I joined SOSTA, and I've been here for almost 7 years now. So when I first joined SOSTA, I was in the performance engineering team, then I moved to product management, and then for the past 3 years I've been in product design, where I've been working on designing features, and this is one of the biggest things we've ever done. So I've been at SOSTA now for 7 years, and it's taken all this time for us to build our product portfolio from cloud test through to touch test, then through to Impulse, which is our monitoring product, and then Data Science Workbench as an add-on to mPulse. And once we had all of those pieces, we were able to complete a vision, which we've been calling the Holy Grail. Lauren called it the Holy Grail, but we really believe truly that this is a Holy Grail feature. And what we're doing is taking mPulse data, and Lauren said some things that I want to reiterate: no sampling, all the data, all the time, kept forever. What you're seeing on the screen right now is a screenshot of the mPulse globe, and it's a really great illustration of that concept: all the data, all the time, kept forever. Each of those little pulses that you see on the globe are beacons, and each of those beacons are a real user hitting a page or conducting a mobile app action, and we're showing that in real time from the geographic location that they're in, as well as with the performance of that action, right? So you see greens, yellows, oranges, and reds, and that happens in real time. So when you watch this for a high traffic web application, you see the globe just lit up all around the world with customers hitting that, and that's where this all starts. So think of each beacon, and Lauren, if you could please move on to the next slide. Think of each beacon as a row in an Excel spreadsheet or a row in a table in a database. And by the way, as we cover this, I'm going to switch between high level and low level. I realize that we have folks on this webinar ranging from hands-on practitioner up through leadership roles. So we're going to touch on the what and the why at the high level, but we're also going to touch on the how. So I'll be moving from high level to low level. So we talked a little bit about the why, what we're doing here to create more accurate test plans, but I want to talk a little bit about the how here. So I was saying, think of each of those beacons that we get, and for a high traffic site, you can imagine we're getting millions and millions and millions of these things per hour, and we keep them all. Every monitoring, and I can say this with authority, every monitoring solution that you've ever seen or ever used is doing some type of sampling or data aggregation to get you that data that you would see if they're even real time, which is a stretch. Most monitoring tools are on some kind of interval, 1, 5, 10, 15-minute intervals, but they're doing some kind of sampling to make that magic happen. They're taking that traffic and aggregating it down and just showing you averages and updates. Well, mPulse is different because we save each one of those rows of data. And not only do we have a row of data for each of those page hits, those beacons that come through, but we have hundreds of pieces of information. And the information that we collect is different than what you might find with some of the tools that you're used to. So here, what we're showing on this slide is that the information that comes with SOASTA mPulse is different than something that you might get from, say, Google Analytics. Right? Our information that we collect is all about user experience. Right? We have some overlap. Right? The blue bubbles there are the things that mPulse collects. Yellow is both, and then the gray is Google. And it's no surprise that the information that Google collects is mostly around SEO and marketing, campaign optimization, and things of that sort, right? But the things that we collect with mPulse are all around user experience. So we want to know how long the page took to load. We want to know how long the resources inside that page took to load. We want to know, some shared information, right, like browser and operating system, right? So some things that there's a little bit of overlap there, but we're getting around 160 pieces of information with every beacon. So, you hear the words big data thrown around a lot. Well, in our case, it really is truly big data. We collect terabytes of data per customer per year, right? Petabytes of information overall. And we save it all the time, no sampling, forever. So the information that you see in mPulse is mostly aggregate level information so that we can display it to you in real time. There's a lot of deep dives that go down to the individual beacon level, but for the most part, when you're looking at average response time and average session length and things like that, that's the stuff that you get from mPulse. But then with the Data Science Workbench component, we allow you to scan and do data science across every individual beacon and every column inside that beacon, and that really is the magic that allows test plan creation to happen. Is we've got all of those beacons, and now we can go to a level and create a test plan that you've never seen before. So could you go ahead and pass presenter over to me so I can go ahead and start sharing my screen?
Yep, sure thing.
So I want to start to dive into how we use all of that beacon data to create this test plan, and this is where the magic starts to happen. All right, so I mentioned about 160 pieces of information inside a beacon. I'm just going to take you through a little stroll of some of that information, what it looks like at the field level, and then I'm going to jump into the product and show you how we use all of these things to create a test plan. Now, through my experience in performance testing, actually when I first joined SOSTA in 2009, if you go back in time, the press release from when I joined the company said that I was credited with creating the first testing and production methodology because of the work that I've been doing for the 10 years prior to SOSTA with testing these large applications in production, testing TurboTax Online in production. I compiled my thoughts and from throughout the years into a methodology of all of the things that you needed to do basically to test your application with 100% assuredness that you would survive your peaks. And that is what SOSTA's PE team, it's what I was using when I first joined, what I trained our PE team on, and what we've grown throughout the years to use with all of our customers is a test plan that has all of these essential components in it that you need to test with confidence. And that includes things that we're going to touch on here, like geographic location that the traffic's coming from, traffic all the way down to the second, minute, hour, day, right? Lots of finely grained, detailed information. And before we had this information at such a granular level, we had to do a lot of guesswork, a lot of probability, guessing. But because we have things scrolling through this list here like browser, right, the page, right, every single page for each of those beacons that comes through, is it SSL or isn't it SSL, right, when the session started, how long the session length was in terms of pages, all right, browser, operating system, device type. We actually have the geographic information, as you saw on the Impulse globe, right? We know where traffic is coming from now. So before we had this type of information at such a fine level of detail, we would have to split the traffic evenly across the country if we knew that, at least for our retailer that was only U.S. based, it was reasonable to assume that the traffic would only be coming from the U.S. So we would do a little bit of guesswork in the test plans, but now we know every single page request from every single customer on a website and where it came from, right, down to the latitude and longitude. It's pretty scary, actually, how detailed we can get. If you watch the Impulse globe closely, you can see users sitting in Central Park, hitting a web application and actually get pretty close to within a block of where that user is. The type of bandwidth connection that they're on, very detailed performance timers, right? Remember we were showing that difference between what we collect and what Google collects, right, with Google Analytics. Where our bread and butter is in all of this fine detail around performance time, right? How long did it take for the whole page to load? When was the DOM ready? When did it load? When was it ready? When did the first byte come across? Right? Now, if you're just tuning in, we're going through each of these 160 or so columns that are in every beacon that we collect, right? Every row of data for every page request on an application. All right. So we've got some other things here like custom metrics, custom dimensions, which are things like product IDs and things that you can send across that you would define. And then on top of all that, not only do we collect all that detailed performance information about the page, but we get it for all of the resources inside the page as well. So most pages these days have hundreds of third-party includes on them. Could be anything from a Facebook like button to images from a CDN. The average page has anywhere from 100 to 300 of these includes. So now we've got even more rows of data, each row for those individual resources. So hopefully you're getting the point here. When I say terabytes of information per year per customer, petabytes of information overall, we've collected billions and billions and billions of these beacons, and we need this fine level of detail to create a test plan. This was the final component that we needed to be able to piece together a complete test plan that follows the SOSTA performance engineering methodology. So hopefully I've helped build a case here for all the data, all the time, never sampled, and kept forever. So we've got this huge archive of data. Once that was in place, I started to see, as the lead designer on this feature, how we could actually piece together literally everything that we need to tell you what you need to test. So I said at the beginning I was going to show you some stuff that you've never seen before. I promise you've never seen anything like what I'm about to show you here. So we have, with all that fine level detail, we have everything that we need to be able to complete a complete test plan. So now I'm going to come up to a high level again, talk about the data science workbench and what the components of the test plan are, and then I'm going to go low again and we're going to look at how we're actually generating all those components. By the time we get to the bottom of this notebook here, you'll know the SOSTA performance engineering methodology, what we dictate that you need in order to build an accurate test plan, and then you'll see how data science workbench actually basically spits it out and just tells you what you need automatically. Huge time-saving feature here, and I'm pretty excited to see where this goes. So, Impulse, that globe screenshot that I showed earlier, that's one of the dashboards in Impulse. As I mentioned earlier, Impulse has mostly high-level aggregate information in real time. It has alerting built into it. It'll tell you if something has gone awry at a high level. The data science workbench is where you do your fine-grained analysis. Basically, since we have all that data in a big data repository, any question that you can dream up, we can answer. Once you've got all the data there, you can go across and ask questions that might not be possible to get answers for in the Impulse dashboards. The data science workbench uses a notebook paradigm, all right? This is where our data scientists or your data scientists would do their hands-on work. It uses a programming language called Julia, which is kind of like Python. Now, the test plan creation functionality is something we've written for you, so you don't have to actually do any custom data science if you don't want to. This notebook ships with the product, so all you have to do is point it at your data and run it with a few configurable parameters. I'm going to come back to these parameters here at the top a little bit later. We're actually going to move right on to the output, and then I'll come back later. Once we've covered what you need to test, right, and shown you all the components that get spit out, I'll come back then and show you how some of the things that we talked about are configurable. So the data science workbench, you put your data science in the cells, and then you run them. Right? So I've run this already on some real customer data, but I obfuscated it so as to not give away any revealing information about this customer. And we packaged everything up into one nice little function here too called gen plan. So all you do is you run these cells, it connects to the big data warehouse, and it runs. Now, let's start to talk about the components that you need to build a test plan that we work with all of our customers to build, and then I'm going to show you how this spits those components out. And at first, you're going to see some things here that you go, oh, hey, I think I can get this existing information from my current monitoring product. But then, as we go deeper and deeper, you're going to realize that what we've done here is again, something that you've never seen. I don't throw that around lightly. Like I said earlier, I came out of webinar retirement to show this to you guys because I wouldn't say that it's something you've never seen before if I thought you'd ever seen anything close to this. This is real hard data science that our data science teams have done to build this over the past 6 months. And so you're going to see some pretty cool things in here. So let's start with what do you need? What's the first thing that you need in order to build a test plan? You're coming from a web application point of view. You're about to try to test for your year-over-year seasonal readiness. And the first thing that you need to know is, what were my peaks from last year? All right. Let's just use the retail example because it's one that I think everybody can relate to, because you're either working for a retailer or you frequent retailers, and everybody knows that Black Friday and Cyber Monday is a big deal. So if you're trying to get ready for Black Friday and Cyber Monday, holiday season 2016, and you want to come up with a test plan, the first thing you need to do is look at last year and figure out when your peaks were. So we've all gone through, and this is speaking from experience, we've all gone through and gone, okay, I'm starting my planning for this year. I need to go back and start figuring out when my peaks were. You might have an idea, like, oh, it's probably Black Friday or Cyber Monday, so you go into your existing monitoring tools or you go into your web logs and you start scouring manually through dashboard ranges, starting maybe with a month, then maybe a week, and then trying to narrow in, and then you're writing on paper, oh yeah, our peak day, we actually had more traffic on Black Friday than Cyber Monday, right? And you're starting to take notes. Well, right out of the gate here, we're going to save you that trouble. You plug in a start and end date. Usually it's January 1st through December 31st of the previous year, but you can zoom in the configurable range into anything. I'm actually just looking at a day here because it's easiest. And then we go through, we look at every individual beacon, right? Could be billions of them depending on how much traffic you get per day, right? Tens of millions or hundreds of millions, certainly for some of the larger retailers out there. And we just tell you straight up, here's your peak day, right? So here's your peak day. Here's how many sessions you had. Here's how many page views you had. Here's how many conversions you had. If you're a SOSTA follower, you know that we're really serious about conversions, right? Because that usually means making money for a retailer. But we're also serious about activity because not everybody has such a clear cut and dry conversion. So for media sites, we have something that we track called activity, right? A key activity. So whether you're using conversions or activities, can be signups, logins, or whatever, We're going to tell you your peak conversions or key activities, and we're going to tell you when that was, right? So here, 8/17/2016, right? Peak day. Then we narrow in and we tell you when your peak hour was, automatically. Sessions, page views, conversions, and time, right? Then we tell you the peak minute, and then we go down and we tell you the peak second. One of the interesting things that I've seen, I've probably run this thing now maybe 200 times for 200 different customers, and one thing that I see almost universally is that the peak day, hour, minute, and second are on different days. It's not uncommon to see, and this is right away, this is something that's going to add a lot of value for you, is people just assume that because I had, my peak day was Black Friday, my peak hour and my peak minute and peak second must be within that peak day, and that is definitely not the case. I almost universally see the peak second, and peak second, we go down to the second because really that's what matters when it comes to concurrency and throughput. It's not necessarily how much traffic you can get in an hour or even in a minute, because if you exceed, it's like a hose, right? It's like a garden hose. You can only push so much through per second, then testing for your peak minute, hour, or day doesn't matter at all because you're not going to survive the peak second. So part of the SOSTA performance testing methodology is you need to know down to the second, and we've been doing this even without being able to tell you what your peak second is. We've been doing this at SOSTA for all of our customers by going through and using worst-case probability scenarios, 80-20 rule and things like that, looking at your peak hour and saying you need to get 80% of your traffic and 20% of the time. Well, now we can tell you, hey, for the time range you specified, we know what peak second is, and here it is. And like I said, that peak second, it's not uncommon to see it like months before when the peak day might have been. So you might have launched an email campaign, or you may have even had a web app hiccup where traffic backed up at a certain level and then flooded through your app all at once. And so we can tell you when that peak second was. We're going to use this information later to build a load profile for you. So already, I can guarantee that you've never seen a product that can go through and tell you this kind of information at this level of detail, this quickly and this accurately, and it's only going to get wilder from here. So then we start to look at session information, right? What was my median session length? So for this customer, it was 1 minute and 34 seconds. Session length, 3 pages. Think time, 22 seconds, all right? MAD is median average distribution, right? Or sorry, median absolute distribution. Is basically, think of it as standard deviation, but for medians. So if you use average, you use standard deviation. If you use median, you use MAD. So the way to interpret this is that the average session duration was 1 minute and 34 seconds plus or minus 1 minute and 28 seconds, which is a lot of variability if you're following along in the data science. Same for session length, 3 pages plus or minus 2 pages. So also very common. One of the main reasons for this variability is that most websites experience something like a 30% bounce rate. So you see, a lot of one-hit sessions where people come and leave. So a lot of variability, things that you might not have known. And hopefully, if you're following along here, you're wondering what it would be like to run this notebook against your data. And I hope that's the case, because usually you learn some interesting things when you run this. Now we've got the peak day, hour, minute, and second. We've got some session information. We're using the peak day to calculate this information, by the way. We're going to use peak day and peak hour and peak second for different things here. So we're using the peak day for session information. We have to use the day because a lot of sessions span multiple hours. So we're just looking at the whole day, the whole peak day that we identified to get this information, right? Then we're going to go down and use that peak hour to figure out what the page group distribution or the page hit distribution was for this time window. Okay, so in that peak hour, tell me my pages and tell me how many hits there were, what the percentage of overall traffic that represented, the think time that people were spending, and then again that deviation, right? And so here in that peak hour, you can see a nice list ordered by volume, by hit volume, of all of the different page groups. All right. You may have seen something like this before, all right? Whether you got it manually from an existing monitoring product or even spit it out automatically, this part isn't hard to do, right? To figure out what pages were hit in an hour, people have been able to do that for a while. But what we're going to do after this is where the real heavy lifting on the data science front came in, okay? So real quick before I move on, category page, product page, search results, home, not surprising things to find in the most popular pages for the peak hour, right? And then here's a pie chart or a donut chart representation of that, just to make it clear, right? If you're giving a presentation, you can throw it up on the board for the execs, 26.2% category, 23% product. Very common patterns for a retailer. Now here's where things start to get crazy. We have every page hit of every user session. We keep all the data all the time, forever. We're looking at we've identified the peak day. We've identified all the most popular pages. Now we're telling you what user scenarios you need in order to test, all right, with accuracy to get coverage based on your previous peak model. And this is magic, right? We've done a lot in this notebook to make it look easy, but I have to stop here for a minute and talk about how hard this is, and there's a reason why you haven't seen this before, all right? You have to go into the big data repository, look at all of the page groups that you've identified, look at how users were hitting all of those page groups, right? Look at the sequences front to back. There's some really cool technology that's happening here, and it has to happen relatively quickly. You can't wait days, weeks, and months to get this data. This information comes back in a matter of minutes across potentially billions of beacons and tells you what the scenarios are that you need to test. At the end of this thing, if you do everything that the notebook told you that you needed to do and you run it, it should generate at 99% or so accuracy exactly what we identified already with the page hit distribution. We're telling you what to do. You may have seen other monitoring tools try to suggest, like, hey, here's the pages that you need to test, but you've never seen them strung together in the order that you need to test them in at the right percentage. And soon, in a minute, I'm going to show you some of the other components that you need. We're just telling you what you need to test. We're taking the guesswork out of it and just telling you based on the data. We're going to come back to bounce path here in a second, but look at the order of these scenarios and the percentages, right? So category page, search results, category page, search results, right? We've looked at all the real users and what they were doing and how they were hitting these. And by the way, one of the first shirts that we ever created at SOSTA said, real users are not normal. And I've spent a lot of time looking at individual user behaviors on websites and, excluding bots. People do weird things on websites. Can I just say that for a minute? I've seen, there's a lot of outliers. So doing this type of aggregation is not easy. You will find one person who's been sitting on a website and they've hit 150 pages in the session, and they've gone back and forth, and then they've refreshed the same page twice, and then they've jumped around. Real users do strange things. They do real strange things. So that's why if you have 100,000 sessions in an hour, it's not easy to say, hey, let's just distill these all down into some paths. So what Ben Polovic on our data science team as the lead data scientist on this project has done here is really awesome. He's looked at all the user behavior, filtered out the outliers, but while still taking them into consideration in order to come up with these recommended paths. And so you will see some repeat pages in here. This may look a little bit different than how you would typically design your performance test. If you're a SOSTA customer or you've worked with our PE team, it won't look that different because we encourage people to do things based on what they see in the real world. So you may go, oh, well, I would never hit category, and then search, and then category again. Well, we would recommend that you do because that's what your real users are doing. So this is in a format where if you execute these, you're going to have the highest degree of accuracy that you've ever had in your performance test. So you're going to want to, and you're going to see changes in how you test in order to get as close as possible. You're just going to need to. This is what real users are doing. Cloud test is revolutionary because we've been testing with real virtual user levels, not using 1,000 users with no think time. We go in, and if you have 200,000 real users during your peak, we test with 200,000 virtual users, right, using cloud locations spread around. So just as we've been suggesting that you don't fake your virtual user count, we're also suggesting that you don't fake the order and the sequences here, because if you run these with the right think times, which I'm going to show you, again, you're going to have the same results at the end of that hour that you had during your real peak. So very important here. So other scenarios in here, you've had a few minutes to kind of check it out. Here's a conversion path, home, registry search, right? Hitting all these pages, logging in, shipping, billing info, right? Now let's talk about this bounce path for a second. This is an important part of any web application. As I mentioned earlier, about 30% is typical as a bounce rate for web applications. So it makes up a huge percentage of page views, and it also makes up a huge percentage of the short sessions and low think times, potentially. So you have to include the bounce path. Now, we look at all the bounce users and also reference, again, this page group distribution table up here to come up with a special scenario that we call bounce path. Down here, you can see this table underneath the asterisk here that has the bounce pages that are most popular and what you need to hit in order to account for that 30% or whatever your bounce rate is, as well as get the right page view counts for these, right? So you're going to have a special scenario that hits the registry, the guest registry here, product page, an SEO page, category, and home page, and you're going to do it at these percentages. And then at the end of that test hour, or whatever the test length is, you're going to end up, again, with that page group distribution being proper and the session lengths being right, and so on. All right, now we're coming down the home stretch here. Now we're going to get into what we call the master table. Now, if you're a cloud test user, the format of the information in this table is meant to mimic a composition. In Cloud Test, you have clips and compositions. Clips are the test cases, and these mimic a clip, right? These are in the format of a clip. So when you record a clip, you'll hit the category page, category again. You'll walk through, and you'll end up with a test clip, right? All of those clips together equal a composition. And this information is displayed here in a way that's meant to be easily keyed into a composition. So we've got the bounce path up here. And now we're going to show you some even more cool information that we're gathering from all that beacon data. And one of those parameters up top, if you got to this point so far, you've heard me mention mimicking the load from the previous year. We do apply a growth factor in those parameters up there as well. So not only are we trying to help you mimic the previous year, but we're trying to account for 10, 20, 30% growth on top of that. So this test plan that gets spit out is based on a growth factor. So these virtual user counts in here are what we're recommending that you run these different clips at to either mimic last year or to get whatever growth level you were shooting for. So if marketing came to you and said, hey, we're going to grow 30% this year on the web, you might go, okay, well, I'm going to plug. Well, if you're anything like some of the apps that I've worked with, you're either going, well, it's 10% every year, so marketing is crazy because they think they're going to get 30%, or you're going, last year you said it would be 10 and we got 30, so you might go, okay, well, we're going to test for 50. And actually the SOSTA performance testing methodology suggests that you test to 2 or 3x your peak load if you really want to have some good buffer there. So these virtual user counts that we're suggesting here are based on that growth factor, whether it's 0, 50, or so on. All right, so we're saying bounce path you should run with 264 virtual users. All right, no think time in parenthesis, so it's just going to run over and over and over and crank those pages out. The percentage of the overall traffic. Geographic location. Okay, so Cloud Test, right, is aptly named because we use public and private cloud servers as load generators. Over the years, we've grown to include every major public cloud provider and many minor public cloud providers, even private cloud vendors, to give you geographic coverage. We've needed to do this for many years, not only to give you confidence that we're testing as accurately as we could, but also to spread out load. A lot of our partners, like Akamai, right, CDNs, they don't want us to, and actually their architecture isn't made for us to generate huge volumes of load from one geographic location, right? It's just not how real users act in most cases. So we always have to spread our load out. And beforehand, if you're a US-based retailer, we would just go, okay, well, let's use, say, Amazon Web Services East Coast and West Coast locations. Let's split it up geographically, right, and just give you a distribution in Azure, Chicago, and just give you 3 points in the US. So check out this other piece of data science, which I'm really impressed with. The first really impressive piece of data science was how we strung together those user scenario paths based on real user data. The other one is how we look at where your traffic should actually come from, what geographic locations. So every single page request that comes through into mPulse, we've got your latitude and longitude down to the block. We look at all of the traffic for the peak day, right, the peak hour, and we look at all the latitudes and longitudes, and we take another piece of information, which is whatever cloud providers you specified at the beginning of this notebook. And so let's say you just said Amazon, right? And actually, furthermore, let's say you just said Amazon East and West. So one of their data centers in Virginia and one of them in California, right? We're going to look at your real traffic, figure out where the majority of that traffic came from, East Coast, West Coast, right? Bucket it out, and then I'm just going to throw this out there for the data scientists that might be watching. We use a mathematical formula called Haversine's formula, which looks at the curvature of the Earth and uses trigonometry to calculate these user populations and what cloud provider locations are closest to them. It's a really cool piece of data science. And so when you see these geographic locations in here, run 127 virtual users from Amazon Virginia, run 43 from Rackspace Chicago. The reason why we're recommending that is because we're splitting up the virtual user load to be completely accurately distributed among the cloud data centers as to where your real users were coming from. I think that that's really cool. We also look at the ramp time, which is really difficult to calculate. You'll look, like, let's use this second scenario here. Notice the think times here that we're recommending you use in between these pages. All right, we're calculating session length and ramp time in tandem with all of these think times so that your session lengths are accurate. We told you earlier on what your average session lengths were, so we're going to mimic those session lengths. We're going to give you a ramp time that's going to ramp up over 8.3 minutes here. And by the time you get up to that and you run for an hour with these think times, with these session lengths, you're going to have as close to real user behavior from the previous year, more so than you could have ever had, right? We're getting really detailed here. So this table allows you to go in and just key this information into the composition editor. This is almost like a tabular form of the composition editor. All the way down, right, through all those scenarios. And then we've just got a nice piece of data visualization here that visualizes those scenarios. If you want to use this in a presentation, we show, hey, homepage, product page, search results with the think times. If you just want to glance through, and this is actually just a great way to present to senior staff or whatever what users were doing in the previous year and what your test plan is going to be for this year. All right, so a little bit of high-level information about the load distribution, right? How many virtual users are going to be coming from what geographic location, a pie chart of that, right? And then a ramp model. And this is the last thing in the notebook here. So it's showing each of those cloud locations, right, and what their ramp time will be. Here's North Virginia, right, ramping up, and then running steadily for an hour. Now, we try by default to compress the test plan into an hour, but we're not limited to an hour. We will use whatever the real ramp time to reach peak loads looked like in the real world. So using Turbotax Online as an example, because I had hands-on experience for a few years there, traffic would build up slowly throughout the day. Right? It would build up, and tax filers would come in slowly and slowly, and it was a slow build. It took all day to get there, right? We can't just come into an application and say, hey, we're going to do a 1-hour test, and we're going to ramp up to your peak load in a minute or 2 minutes or 5 minutes or 10 minutes. So these ramp times are not only trying to help mimic the model from the previous year, but they looked at the real traffic and looked at the peak seconds and said, what's reasonable? Look at the velocity of incoming user traffic and use that to create your ramp times. And so this is the last piece of data in the notebook here, and we're going to turn it over for Q&A in a minute, but I just need to recap what I've shown here because, we've gone high level, low level. We've looked at all the components of the performance testing methodology that SOSTA has been using for years, and we've tried to create, and I think we've done it successfully, some data science that automatically spits all of that information out. So we know the methodology because we've created it. We've been using it successfully for hundreds of customers for years to make sure that they don't crash or have any issues during their peak traffic periods. We took that and said, how can we get that information from all of the beacons that we've collected and through some really heavy lifting on the data science front. And again, the stuff's not easy. This isn't like simple SQL queries, right? There are patent pending algorithms that we've created that are behind the scenes doing this work, and it's really complicated work. That's why you haven't seen anything like this before. And I can say also proudly and confidently that we really are now only one step away from being able to automatically create the test assets, right? We're pretty close to being able to create test clips and a test composition that reflects this information. Initially, even if it's even if it's only a skeleton, doing things like browse paths, if you're a performance tester or any type of tester on the line, browse paths are easy. Category, search results, category. We have some ideas about how we could create these. The stateful session scenarios are a little bit harder, right? The things where you have to search for some things and then log in. You need some things like seed data, but we're closer than we've ever been to being able to create this automatically, and so it's a really exciting time. We in the press release for this feature a few weeks ago, we said that there haven't been too many revolutions in performance testing over the past 25 to 30 years that performance engineering has been a thing, but I'm happy to say that SOSTA has led the recent ones with cloud testing, all right, with dynamic ramp, being able to dynamically change load in real time without having to stop the test, and then on to test plan creation. This is a big one. So like I said, it's why I came out of webinar retirement, to make some noise. So hopefully you like what you've seen here, and you want to get your hands on it. There's nothing like running this on your own data and figuring out some things that you might not have known. All right, when your peak second was, when your peak minute was, what your users were actually doing. No more guesswork. No more guesswork. We want to take the guesswork out of it. So hopefully you've seen some cool things here, and maybe you have some questions. So with that, I would like to hand it back to David to field your questions for us.
Okay, thank you. That was great. So we do have some questions, but I want to remind people, if they do want to ask a question now, to type it into the question box, and we'll get to as many as time allows. The first question we have is the test plan generated automatically, or is there any performance engineering work involved?
That's a good question. Oh, sorry, am I still there?
Yeah, you're still there.
Oh, okay. Yeah, sorry, that was strange. Yeah, the question window popped away. So yeah, that's a good question. It is actually created automatically. The performance engineer, other than possibly needing to tweak some of the parameters, we've got pretty good defaults out of the gate. In that notebook, you might want to tweak what cloud provider locations you're willing to use. You might want to tweak that growth percentage that I mentioned. But other than that, once you point it at the database where all the beacons are, you just click run. And it could take anywhere from seconds to minutes, depending on how much traffic and what time range you're looking at. But all of that stuff in there just gets spit out. It's one function called generate test plan, and it just runs and spits it all out. So you can tweak things. Part of the SOSTA performance testing methodology also dictates that you do some key transactional level testing. So we recommend that you test your features in isolation as well as a whole. What you saw is a complete readiness model, but there may be times where you just want to test logins, or you just upgraded or changed your search functionality and you only want to run searches. So you have questions like, when were peak searches last year? And how are users searching and things like that? Well, you can actually go into the parameters of that notebook and tweak it. You can say only look at this page group, or only look at these page groups, and only from these cloud providers, and you can get detailed transactional level testing too. But the PE doesn't have to do anything. Performance engineer doesn't have to really do anything other than point it at the database and run it. So we also have a version of this which I didn't show, which is the test plan creation report. If you saw the notebook and things like data science turn you off and you just want to know what to test, we have a really nice report that the Data Science Workbench will spit out too. It's a PDF that it has everything that I just said basically in this webinar. It says, here were your peaks, and here's why your peak second is important, and your peak minute is important, and here's what the page groups are. And you can just read it front to back. It's a beautiful report and just tells you what to do. So if you don't want to have to go in here, just go into Data Science Workbench and pump the report out, and that's it.
Excellent. Okay, here's an interesting question from one of our attendees. They're looking for a few examples of the kinds of issues, whether they're functional or non-functional, that these top 20 companies in 2015 and 2016 were experiencing in their applications.
Lauren, do you want to take that, or do you want me to chat about that?
The issues they were experiencing? Like the
yes.
load earlier?
Right.
Yes. A lot of those were load-based. They hadn't tested to the right load. So, like Dan, we call him Bartow. Like Dan was saying earlier, our methodology is to test to multiple 100x what you might expect, and that's because you're not sure what's going to happen, right? You don't know if you're going to be the Pokemon Go and you're going to just take off. So a lot of what happened in a lot of those instances was not testing to enough load. Pokemon Go also had issues around devices and battery consumption that they could have tested for that they didn't. Some of the instances were not testing to, today's use cases. So with Delta and Southwest, they've added on a lot of functionality for today and how people want to experience their airline flight with, apps and mobile check-ins and automated bag check, but they don't necessarily have the infrastructure in the back end to handle that. And if they haven't tested for that, and if you're going to provide that functionality but you can't support it, you're not really going to create a better user experience for your customers. So you may have to create some sort of transition plan. But if you've tested for those scenarios, if you've tested out what happens, if so many people are using the app or so many people are doing mobile check-in, how does our backend handle that? Then you know where you need to address your issues, and maybe you can set up some mitigation plans while you're in transition. So those are some of the issues. HSBC actually had a couple of issues. One of them happened right before a long weekend and on a Friday payday, and people actually couldn't get paid until after the weekend. So there can be some real impact. And so those were some of the issues that were encountered from those companies.
Very good. I don't know, about halfway through that answer, you kind of turned into Max Headroom for a minute or so, but I hope people got the gist of what you were saying there. I guess this next one would be for Dan. I think the question is, how do we exactly identify the significance of the bounce path in performance test scenarios?
Yeah. Well, it starts with bounce rate. Most people probably know their bounce rate. That is something that you can get from something like Google Analytics. It starts with bounce rate, and depending on the retention and the engagement of people on your application, it can be anywhere from, it's rare to see anything lower than 10. You have to have a really engaging site, but it's more common to see things like 30 to 40%, and so it's a huge part of the traffic. And usually, it might be something like an email campaign, something that's passed around on social media, but people come and by the way, that initial user experience is so important that if the first experience, if that first page is poorly performing, the bounce rate will go up, and we've seen that time and time again. People are just twitchy. They don't want to wait for things to load. So if that, and usually you saw a product page was in that bounce path, right? It's, people might search on Google and go, hey, I need a power washer, and then they'll show up on a website, right? And if that first site that they hit it takes more than 4 seconds to load. If they see white, and then it's they'll just hit back and they'll hit the next site in line. So the bounce path and then is really important because it makes up a huge percentage of the traffic, and oftentimes it represents it can actually help you identify a problem on your site, because those initial landing pages, the performance of those directly relate to how people move on down the line. But it's important because it affects the session length. If 30% of your traffic hits one page and leaves, it's going to bring your sessions down. So if you don't have one of those bounce paths in your test plan, and that you're not testing for that, your numbers are going to be pretty skewed, not only from a front-end perspective, but all the way through the product architecture. Those one-hit and quit scenarios are really important.
Excellent. Okay, another couple of questions. We'll kind of put them together about mPulse. The questions are, does mPulse assist in capacity planning, and can you install it on premises?
Sure, I can help with that. So for capacity planning, definitely, because as we've shown here, you'll be able to see all of your traffic. Using the data science insights and elements of it, you can figure out how much traffic you need to plan for, and you can do growth calculations around that. We can also help even with your resourcing from a capacity standpoint, because we can help you figure out exactly what you need to test, where you need to optimize, and kind of what resources you're going to need to be able to get that optimization done. In regards to if it can be installed on-premise, it is currently a cloud-only solution. That is our plan, so there's not a way at this point to install it on-premise. But we do have a lot. We can answer a lot of your questions. Usually, most people that want to install it on-premise, we're able to accommodate it still within the cloud. We're able to read whatever questions they have around it.
Very good, thank you. Okay, so we have just another couple of minutes. If people want to get any last questions in, now would be the time to submit them. So let me continue on now with the questions. So is a RUM subscription required to take advantage of the test plan generation?
Actually, no. So we are offering this as a service, and if you have Impulse, that's fantastic. That gives us more data that we can work with, especially if you're a current Impulse customer. But if you don't have Impulse, we will actually, as part of the service price, we will tag your site for a minimum of 2 weeks to collect that data and then create the script from that.
Very good.
Create the test plan from that. So there's no requirement for any SOSA software license purchase for this, this service.
That's very good news for a lot of people. Okay, so I guess our final question takes us back to the bounce path, and the question is, how do we identify what our bounce path should be in the case of a retail client, as an example?
Yeah, that's, I think, so in the notebook, in the notebook that I showed, I'll say this is one of the more interesting things to come out of this data science, is that beforehand, pretty much everybody was limited to being able to look at a page group table, like what I showed, right, for a peak window. So you'd go into an analytics product and you'd go, hey, you know, even an Impulse, until we had this level of granularity, you could look at a peak hour and see what pages were getting hit in that hour, but you didn't really know which percentage of those were just hitting it once and leaving, versus which percentage were hitting, you know, the product page and then moving on. And so that's first thing that we've established. A lot of questions about bounce path here, so I guess people are latching onto that. It is a really important thing because, like I said, it makes up a huge percentage of traffic. So first off, if you don't know what your bounce percentage is during your peaks, you should go figure that out. Impulse will tell you that. But you're going to figure out that it's somewhere between 10 and 40%. And then from there, you need to figure out what pages are getting hit in that period of time, right? And that's where Data Science Workbench with this test plan creation functionality, we just come out and tell you, right? We look at that, we identify the page group table for the peak hour, and then we look at all the user paths and we look at all the bounces, right? A bounce is defined as hitting the page once and then leaving. So we figure that out, right, by scouring and remembering from all of those page hits, and we figure it out, and then we break it down. We say, hey, you should have a bounce path that hits product page, category page, and home page. 30% should be this, 30% should be that, 20% should be this. And if you need a think time, we'll throw a think time in there, but the net of that is that when you run that clip, and if you were to compare it to the previous year, you would get N number of bounces off the product page, N number of bounces off the category page, and it would directly match what you had last year. Again, no guesswork. We're just telling you what you need to do, and we're doing it such that when you execute it, it'll be as accurate as possible, and it's very accurate, more than 99%.
Great, Dan. Okay, so we're just about out of time, but I want to ask Dan and Lauren to take maybe another 15 seconds, 30 seconds each, and give us their final takeaways of what they think you fine attendees should be leaving with here today. So Dan, why don't we start with you, and then we'll go to Lauren for a quick summation and takeaway.
Definitely, thanks. Yeah, thank you everybody for attending. I really appreciate it. Hopefully, well, you should have seen something here that you've never seen before. I can guarantee that because I've never seen anything like this, and my ears to the ground all the time. The key takeaway for you here is that the offerings that we have here are built for enterprise. They're built for performance testers. They're built to give you the highest level of confidence that you could ever have, and this is one of the ways that we're going to be doing that over the next few years. You're going to see this. You're going to hear about it. You've never been able to have such confidence in what you need to test because we're literally gone down to the second. We've gone down to every single page view with 160 pieces of information about every page view. You got everything that you need here to be able to test with confidence. And so this is big. Hopefully we saw something cool today.
Excellent. Lauren, any final thoughts?
Yeah, sure. So I think Dan and I and everyone here at Cisco are really excited about this. Most of us have testing backgrounds, and we've been in the trenches. So just test smart. Make sure you're testing the right thing, and use run-based testing to reduce that test cost and risk, and then ultimately you're just increasing your quality, you're increasing your user experience. They're going to come back. They're going to use your site, and that's going to increase your revenue and bottom line.
Excellent. Thank you so much. Okay, I'd like to certainly thank SOSTA again for bringing this presentation to us, and thanks to Dan and Lauren for presenting today, and thank all you attendees for hanging in there with us. We really appreciate it. So until next time, once again, I'm Dave Rubenstein, Editor-in-Chief of SD Times. Take care.